Hey everyone, so this is lesson 9. We're moving into line plots. And we're going to stay here for quite a while, okay? So get ready, here we go. So we've already talked about the different parts that have to be part of a bar graph and a line graph. And some of those parts are the parts in a line plot too, but they're a little bit different. But before I get into that, I want to talk about a brand new vocabulary word, okay? So our new vocabulary word is the word outlier, and you're going to see this right here on the page. Let me grab this. So we have outlier, okay? So when you look at that word, you can see out and liar, okay? So here's technically the definition of what an outlier is. An outlier is a piece of data, so a number, that is very different from the other data. It lies, meaning it's on the number line, it lies far out or away from the other data. So let's look at an example here of what an outlier is. Okay, so here I have my number line. It's going from 8 to 16, and we see that most of our data is right here all bunched together between 8 and 11. And then way out here, far away from all the rest of this that's bunched together, we have the number 16. So 16 is an outlier because it's far away from the rest. And when we say far away, we're talking like more than 3 or 4 numbers distance from everything else. So when everything else is bunched and that's far away, okay? So if like you technically, I guess, could have 2 outliers if there's something far away to the left and if there's something far away to the right, but usually there's just 1 outlier, but there doesn't have to be an outlier in your data set. It's just something that might happen. Okay, so let's talk about the important part of today's lesson. The parts of a line plot. Okay, so some of this is going to sound really familiar. So number 1, a line plot needs to have a title. Number 2, a line plot needs to have a number line, and it's just a horizontal one. So it's kind of like the x-axis, but we don't call it the x-axis. It's just a number line with a consistent interval, which means you have to decide what are you counting by, and then you have to do that the entire way down the number line. And then you need to have a label for your number line. So what do those numbers stand for? And then you need to properly place your X's to show your data. Okay, so let's look at an example here. So it's how do I make a line plot with this data? So over here at the right, I have my data and it's rows lengths, so the lengths of some roses. And we have kind of like, I don't know, our little number vomit here where everything's kind of confusing. So the first thing you want to do is look at the data and find the smallest and largest numbers and then put them in order, which I already did. The smallest is 11, then it's 14, 15, 16, 17, 18, and then 29 is our largest, okay? So I need to make a number line that includes all of that information from 11 through 29. Now it would be super simple if I could just do a number line and just make it look like this and be like, ooh, number line, 11, 14, sorry, it's a really sloppy 14, 15, 16, 17, 18, 29. Man, if only math were that simple and we could just do it like that. But when I look at that number line, there is no consistent interval. And number lines are based on having a consistent interval. And here I would be jumping +3, +1, +1, +1, +1, and then +11. So that's not a consistent interval. So we can't do that. Life is not that simple. So get rid of that garbage. Okay, so we have to have a consistent interval to make our scale. And remember, it doesn't have to start at 0 because it's a line that goes forever in any direction. I'm going to use an interval of 1 because most of our numbers are pretty close together. So I usually start at the number 1 less than your smallest. So I started at 10 and I went the whole way to 30. And all of my numbers are in between. Okay, so writing that out, just draw a nice line, do all your little hashes. That's what these things are called. These are hashes. Okay, do all your hashes and put your numbers underneath. Okay, and then you have to have a title. So I looked up at my data, ooh, rows lengths. So that's what my title is going to be. I need a label under the number line to explain what the numbers stand for. So when I have an 11, that stands for 11 inches. So, sorry, let me scroll this down so you can see it. Oop, there's our label. Okay, and then the last thing we do is plot our X's above the numbers. So I have 1 at 11, 1 at 14, 15, 16, 17, 18, and then here at 29. So my question would be to you guys, is 29 an outlier? The answer is yes, it is, because it is very, very far from all the rest of the data, which is pretty much bunched together between 11 and 18, and then 29 is way out there all by itself. Okay, so if, let's just say, for instance, there was another rose length that was 28, so at this point, it's not by itself, so it's not considered an outlier anymore. But because there isn't anything out there, it is an outlier. Okay, let's look at some questions to go along with line plots, because I'm going to kind of go back and forth between making them and making sure that you know how to analyze them. So here I have a line plot that has a label of giraffe heights in feet. And then we have some information plotted. If we look at this number line here, the interval is 1 because it's jumping one number as it goes. Okay, so the first question is, how many giraffes are 14 feet tall? So pause for a second, come up with an answer, and then come back. Okay, so right here, how many giraffes are 14 feet tall? Well, we're looking at this right here, and our answer is how many X's there are. So there are 2 giraffes that are 14 feet tall. Second question says, what is the most common height of the giraffes? So most common means which one is happening, which height is happening the most, are most of the giraffes. So our answer for that one, think about it. Okay, so our answer for that one, which one is the most common? Well, right here, there's 3 that are 15 feet high. So that's our most common answer. So 15 feet is the most common height of the giraffes that were surveyed or measured. So the third question is, how tall is the tallest giraffe on the line plot? Okay, so look at the line plot, figure out how tall the tallest giraffe is. Okay, so tallest, well, it's not 14 feet, 15 feet, 16 feet. There are no giraffes that are 7 feet tall. Our tallest giraffe, there's actually 2 of these guys. The 2 tallest giraffes are 18 feet tall. And then the final question, is the number 18 an outlier? And I hope that you're thinking, no, because it's not. It is a little bit away from everybody else, but it's not far out there. There's only one number in between them. So 18 is not an outlier. The other reason is because there's 2 of them, and it's not one thing all by itself laying far out. So the answer is no, it is not an outlier. Okay, so we're going to practice. We're just going to go back and forth between making line plots and answering some questions about line plots. So up at the top, ignore that's in blue. This would be if I were doing it in the classroom with you guys. So what we're going to do is we are going to put this information onto a number line. So in this case, my data is just numbers, and I don't have information to say what's my title or what's my label, but I can make that up. Let's just say it is, oh, I don't know. Sorry, I'm losing my, okay, number of pets. Okay. So each number would stand for how many pets somebody has. So we could have a title of pets and a label of number of pets. Okay, so now we need to figure out our number line. Our smallest number is 3 and our largest is 26. So our number line has to go from 3 to 26 with an interval. So I could count by ones and do an interval of 1 and do 3, 4, 5, 6, but that's going to be a pretty long number line. I can go by 2s, and I would go 2, 4, 6, 8. But if I do that, most of my numbers are not going to end up on the number line. So here's what I'm going to do. I'm going to do an interval of 3. Okay, so I'm going to start with 3 right here. So 3, and then 6, 9, 12, 15, 18, 21, 24, and 27. Okay, so that gets us from 3 to 26. Okay, so once we have our title, our label, our scale with a consistent interval, then we can plot our x's. So we need to put an x at 6. We need to put an x at 9. We need to put an x at 3. Oh no, we need to put an x at 11. How am I going to do that? Well, 11 is going to be between 9 and 12. Okay, so in between 9 and 12 is 10 and 11. So let's imagine, I'm just going to just say imagine, if this is 9, 10 would be about here, 11 would be about here. We do not want to put those hashes on there. I'm just saying, kind of imagine that would be there, okay? And so we're going to put an X floating up in the air above our imaginary 11 spot, okay? So we need to know, oh, between 9 and 12, there's 10 and 11, and that's floating right there above where, really close to where 11 would be. And then 26, same thing happens. We don't have a 26 on our number line, so here's 24. So 25, 26 would be in between. So we're going to have our X floating right up in the air, just a little to the left of the 27. Okay. On our line plots, sometimes, depending on the interval that we pick, we do have numbers that are floating in between the hashes for where they're supposed to be. Okay, guys, let's look at another one. Okay, so I have a data table, and then I have some questions over here. So the first question is, what will the title of your line plot be? Looking at the data table, I'm going to say my line plot is going to be snowfall. And I just kind of made that up based on the fact that this is about inches of snow. And then what label will I use for my line plot? Well, looking at this here again, I know it's in inches of snow. So my numbers are all going to stand for inches. Okay, so we have inches of snowfall. And then what will be the first number of my number line? Well, the smallest piece of data is a 2. And what will be the last number? Well, my biggest piece of data will be a 6. So I'm going to go from 2 to 6. So I have to create that number line, 2, 3, 4, 5, 6, and then I have to plot my X's. So now here for 2 inches, I have 5. So I have to be 1, 2, 3, 4, 5. At 3, there's nothing, but that still needs to be on that number line because of that interval. 4, we have 2. 5, we have 4, and then 6, we have 2. So there's an example of a number line using an interval of 1 and having a few more X's than our other examples. Okay, guys, this is going to be the last one I do. So we have some spelling test scores, and there's a whole bunch of numbers here. And the first question is, what's the highest and lowest? Well, the lowest is 15, and the highest is 20. So my number line is going to have to go from 15 to 20. When things are kind of all confusing like this, the easiest thing to do is to create a real quick frequency table and then do some tally. So just going through 16, 1, 18, 17, 19, 18, 20, 18, 17, 20, 19, 17, 18, 19, 15, 17, and 16. So now I can see how many X's I need to do. So these are spelling tests, so that's going to be our label. And then, sorry about that, I'm running out of time, so I'm going a little fast here. And then our label down here would be score. So our title is spelling tests, and the score is down there. So then I need to come up, I have to go from 15 to 20. So I'm just going to do an interval of 1 because they're right next to each other. So I'm going to start here, 15, 16, 17, 18, 19, and 20. And then I'm going to place my X's. So there's 1 at 15, there's 2 at 16, there's 4 at 17, 4 at 18, 3 at 19, and 2 at 20. So that's what our number line would look like. Okay, guys, so I'm going to give you a little practice on this here as an activity. So good luck with that and have a great day.